Hello everyone, I'm Yun-Hsuan from National Taiwan University. I'm excited to present our work, OCID-Ref, a 3D robotic dataset with embodied language for clutter scene grounding. This work is done with Ke-Jyun Wang and my co-authors from National Taiwan University. This is the outline for my presentation. I will start with our motivation and then present our collected OCID-Ref dataset and the proposed method. Then, I will show experiments and results. Finally, the conclusion. So, let's start with the motivation. Imagine a scenario where the user is asking a domestic robot to pick up something. Based on the given instruction, the robot needs to understand the meaning of your words and scan through the environment to identify the target item among the objects on the table. But how to achieve this goal? For human beings, when we try to understand the semantic meaning from the sentence and connect with the environment we observe, we may focus on some visual cues to localize the target. So, we expect the robot first detect the position of the referent, and then, based on the spatial relation, the robot can finally identify the correct object and pick it up. This is the visual grounding task in human-robot interaction. To be more specific, given an image and a referring expression, the model predicts the segmentation mask. Some efforts have been made to deal with visual grounding. However, no current dataset is suitable for robotic grasping. For example, RefCoco contains only images with people and daily necessities. Besides, they did not address the occlusion problem, which is challenging in working environments such as office and warehouse. Observing the challenges, we propose a novel OCID-Ref dataset for human-robot interaction. First, we use a robotic indoor dataset, OCID, which consists rich 3D point cloud data and the point-wise instance labels for occluded objects. Then, we ask annotators to label fine-grained attributes and relations such as color, shape, size, or spatial relation. Based on these attributes, we follow up the predefined templates to generate the referring expressions. Here are some examples of our OCID-Ref. The upright sentence, the cereal box closer to the navy board, is a referring expression, where navy is the attribute and closer to is the relation. Compared to existing visual grounding datasets, OCID-Ref is the first dataset featuring both 3D signals and object occlusion, which are both crucial for visual grounding for human-robot interaction. Besides, OCID-Ref has more challenging and cluttered examples than the current 3D visual grounding datasets. Next, we introduce the method. This is the overall pipeline of our method. We evaluate our OCID-Ref dataset with a state-of-the-art model, DGA, which is a graph-based referring model proposed in ICCV 2019. Also, to evaluate the contribution of each modality, we construct 3 versions of models, 2D, 3D, and Fusion. In 2D setting, we take an image and the referring expression as input and follow the same settings in DGA to predict the 2D mask for the target object. In 3D setting, we change our input from image to point cloud and predict the 3D mask for the target object. In Fusion setting, we combine the image and point cloud as the input and remain the same settings from 3D version. As for the graph in 3D and Fusion model, we replace the information on the edge with the 3D bounding box and the ROI feature. Next, We will present the experiments and results. To evaluate the model performance in different clutter levels for each version, we follow OCID to separate the scenes into 3 clutter levels: free, touching, and stack, which means clearly separated, physically touching, and being on top of each other. According to the result, the performance is negatively associated with the clutter level, indicating that the occlusion makes the text more challenging. Also, using 3D signals enhance the overall performance on all clutter levels. We visualize the results with different referring expressions in the same clutter scene. Correct answer is marked as green, otherwise as red. Results demonstrate that the fusion method outperformed the 2D and 3D version, while they all fail on the long referring expression. Here are some takeaways for you. We introduce the text of grounding feature the occluded object in clutter scene with embodied language. Besides, we provide the OCID-Ref dataset consisting of about 300,000 referring expressions from 2,300 scenes with provided image and point count inputs. Thank you for listening, and feel free to contact us if you have any questions.